If you like our content, please don't forget to subscribe and follow our channel. Thank you for your support. Welcome to our deep dive into the cutting-edge world of science and technology. Today, we're going to explore groundbreaking discoveries that are not just pushing the boundaries of human knowledge, but are also poised to reshape our future in ways we could once only imagine. From revolutionary gene editing techniques that have the potential to eradicate diseases, to the latest advancements in space exploration, we'll journey through the frontiers of innovation. Imagine a future where genetic disorders are a thing of the past, where we harness the power of the sun right here on Earth for limitless clean energy, and where machines can create art and music that touch the soul as deeply as human artists do. These aren't far-off dreams. They are realities we are rapidly moving towards. Each breakthrough we explore is not just a technological achievement, but a solution to some of the world's most pressing challenges. We'll look at how CRISPR technology is revolutionizing medicine by allowing precise edits to our DNA, potentially curing genetic diseases like sickle cell anemia and muscular dystrophy. We'll explore the strides being made in fusion energy, a cleaner, more sustainable power source that mimics the processes happening inside the sun, offering the promise of virtually limitless energy without the harmful byproducts of current technologies. Space exploration is reaching new heights with the James Webb Space Telescope, which is uncovering the secrets of the early universe, spotting the first galaxies that formed after the Big Bang, and even helping us identify planets that could harbor life. But it's not just about looking out into the cosmos. We're also looking inward, using artificial intelligence to push the boundaries of creativity. AI is no longer just a tool for automation. It's collaborating with artists, generating unique works of art, music, and literature, and even helping us solve complex scientific problems that were once beyond our reach. Quantum computing is another area poised to revolutionize our world. With computers that leverage the strange properties of quantum mechanics to perform calculations that would take traditional computers millions of years. This could unlock new solutions in everything from cryptography to material science. And as we face the growing threat of climate change, innovative research is providing new ways to tackle this global crisis. From advanced climate models that predict the impacts of global warming more accurately, to groundbreaking technologies like carbon capture and green hydrogen, science is at the forefront of the fight for our planet's future. Finally, we'll dive into the world of biotechnology, where advancements in understanding the aging process are paving the way for therapies that could extend human health span, allowing us to live longer, healthier lives. Each of these topics represents a significant leap forward. They are interconnected, with advancements in one area often driving progress in another, creating a cascade of innovation that could redefine what it means to be human. In exploring these discoveries, we will not only delve into the science behind these breakthroughs, but also consider the ethical and societal implications. As these technologies develop, we face new questions. How do we ensure these tools are used responsibly? How do we make sure that their benefits are shared equitably across all of humanity? So, join me as we dive into the cutting edge of science and technology. By understanding these discoveries, we can better prepare for the future they are creating, a future that is already beginning to unfold before our eyes. Buckle up, because the future is now, and it's more incredible than you've ever imagined. Let's dive into CRISPR technology, a revolutionary gene editing tool that's changing the landscape of medicine and biotechnology. CRISPR, or clustered regularly interspaced short palindromic repeats, is based on a natural defense mechanism used by bacteria to fend off viruses. Scientists have harnessed this system to create CRISPR-Cas9, a tool that allows precise cuts in DNA, enabling the insertion, deletion, or modification of genetic material. This groundbreaking technology has opened the door to treating genetic disorders by directly targeting the faulty genes. At its core, CRISPR-Cas9 functions like a pair of molecular scissors guided by a strand of RNA that matches the DNA sequence to be edited. Once Cas9 finds its target, it makes a cut, allowing scientists to alter the DNA at that exact location. But CRISPR technology doesn't stop at Cas9. Advancements like CRISPR, Cas12, and Cas13 have expanded its capabilities. Cas12, for example, makes staggered cuts in DNA, which is useful for more precise insertions with fewer unintended consequences. Cas13 targets RNA, not DNA, which is valuable for silencing harmful RNA without altering the genetic code, offering potential treatments for viral infections and diseases caused by RNA malfunctions. Prime editing is another leap forward, described as a genetic word processor that can perform search and replace functions directly within DNA. Unlike traditional CRISPR methods that rely on double-strand breaks, prime editing minimizes errors, making it one of the most accurate gene editing techniques available today. The potential of CRISPR extends far beyond the lab. In clinical trials, CRISPR has shown promise in treating genetic conditions like sickle cell anemia and beta thalassemia. Patients with these disorders who have undergone gene editing have experienced significant improvements, with some even becoming symptom-free. For instance, in sickle cell anemia, CRISPR edits the faulty hemoglobin gene, addressing the disease at its source rather than just managing symptoms. In muscular dystrophy, another area of intense research, CRISPR is being used to repair mutations in the dystrophin gene. This has the potential to halt or even reverse muscle degeneration, providing a new hope for millions affected by these debilitating conditions. Beyond human health, CRISPR is also being explored for agricultural improvements, such as creating crops that are more resistant to pests, diseases, and environmental stresses. It's already being used to develop rice and wheat that can thrive in challenging conditions, helping to secure food supplies against the backdrop of climate change. However, with great power comes great responsibility. The ability to edit genes raises profound ethical and societal questions. Should we edit human embryos to eliminate genetic diseases? Where do we draw the line between therapeutic applications and enhancements, such as increasing intelligence or physical abilities? The debate over designer babies is already heating up, and as the technology becomes more accessible, these discussions will only intensify. Technical challenges also remain. One of the major concerns with CRISPR is off-target effects, where the edits occur in unintended places in the genome. While significant progress has been made in reducing these errors, ensuring the safety and accuracy of CRISPR is still a major focus of ongoing research. Looking to the future, CRISPR could potentially be used to combat infectious diseases by editing the genomes of viruses and bacteria themselves. It's also being explored as a tool for ecological engineering, such as editing the genes of invasive species to control their populations and protect native ecosystems. In cancer research, CRISPR is playing a pivotal role in developing personalized therapies. By editing a patient's immune cells to better recognize and attack cancer, CRISPR-enhanced CAR T-cell therapies are showing promising results, even in hard-to-treat cancers. The story of CRISPR is still unfolding, but one thing is clear. It has the potential to revolutionize nearly every aspect of biology and medicine. From curing diseases and improving food security to tackling ecological challenges, CRISPR is not just a tool. It's a transformative force for the future. As we continue to refine this technology, the possibilities are as vast as our imagination, and the future of CRISPR is bright and full of promise. Let's turn our attention to fusion energy, a technology that could redefine how we power the world. Fusion is the process that powers the sun, involving the fusion of light atomic nuclei to form heavier ones, releasing vast amounts of energy. Unlike current nuclear power, which relies on fission, fusion promises a nearly limitless supply of clean energy with no long-lived radioactive waste. Achieving fusion on Earth has been a scientific dream for decades, but recent breakthroughs suggest we're closer than ever to making it a reality. The National Ignition Facility in the United States recently achieved a significant milestone known as ignition, producing more energy from a fusion reaction than was used to start it. This is a critical step toward creating a sustainable and practical fusion power source. However, challenges remain. Fusion reactions require extremely high temperatures, over 100 million degrees Celsius, hotter than the core of the sun. At these temperatures, hydrogen atoms become a plasma, a state of matter where electrons are separated from nuclei. Containing this plasma is one of the biggest hurdles. To manage these conditions, researchers use powerful magnetic fields created by devices known as tokamaks. A tokamak uses a donut-shaped chamber to trap the plasma with magnetic fields, preventing it from touching the walls of the container. The ITER project in France, one of the largest international collaborations in scientific history, aims to demonstrate sustained fusion reactions in a tokamak on a large scale. Another approach is stellarators, which twist the magnetic fields into complex shapes to better confine the plasma. While still in experimental stages, stellarators offer potential advantages over tokamaks, such as continuous operation without the need for pulsing the plasma, which is a common challenge in tokamak designs. Beyond tokamaks and stellarators, researchers are exploring inertial confinement fusion, which uses powerful lasers to compress and heat a small fuel pellet, achieving the conditions necessary for fusion. The National Ignition Facility's recent success with this approach has sparked renewed interest and funding. The potential of fusion energy extends far beyond electricity generation. It could provide a virtually endless supply of clean water through desalination, enable deep space travel with fusion-powered spacecraft, and even play a role in producing sustainable fuels. However, scaling fusion to practical power plants will require continued innovation and investment. Companies like Commonwealth Fusion Systems and Helion Energy are leading the charge with new technologies and approaches that could bring fusion power to the grid within the next decade. They are working on compact fusion devices that aim to reduce the size and cost of fusion reactors, making them viable alternatives to traditional power plants. Fusion energy is not without its critics. Some argue that the time frames and costs associated with developing fusion are too optimistic, and that immediate investment should focus on existing renewable technologies like wind and solar. However, proponents believe that fusion's unique benefits, such as its ability to produce energy 24/7 without reliance on weather conditions, make it a crucial piece of the future energy puzzle. Moreover, fusion produces no carbon emissions and only minimal short-lived radioactive waste, unlike current nuclear fission reactors. The fuel for fusion, isotopes of hydrogen like deuterium and tritium, is abundant. Deuterium can be extracted from seawater, and tritium can be bred from lithium, making fusion fuel virtually limitless and widely available. As we look to the future, the promise of fusion energy is not just about power. It's about a paradigm shift in how we approach energy production. It represents the hope of a cleaner, more sustainable world, where our energy needs are met without compromising the health of our planet. The road to fusion energy is challenging, but the potential rewards are immense. With continued dedication, innovation, and collaboration, fusion could become the cornerstone of a new energy era, providing power that is as clean as the sun itself. The James Webb Space Telescope, or JWST, the most powerful space telescope ever built, which is transforming our understanding of the universe. Launched in December 2021, JWST is a marvel of engineering, equipped with a massive sun shield and a primary mirror more than twice the size of Hubble's. This allows it to observe the universe in unprecedented detail, particularly in the infrared spectrum, which is crucial for peering through cosmic dust clouds that obscure visible light. One of JWST's key missions is to study the formation of the first galaxies after the Big Bang, providing insights into the origins of the universe. Its powerful instruments have already started to reveal high redshift galaxies, which are some of the earliest structures ever observed, helping us to understand how galaxies evolved over billions of years. But JWST's capabilities go beyond just observing distant galaxies. It's also equipped to study exoplanets, the planets orbiting other stars, in more detail than ever before. By analyzing starlight that passes through an exoplanet's atmosphere, JWST can identify the chemical composition of these distant worlds, including the presence of water vapor, methane, and other potential signs of habitability. This makes JWST a crucial tool in the search for life beyond our solar system. JWST's infrared vision is also providing stunning new views of star-forming regions within our own galaxy. It can see through the dense dust that shrouds these nurseries, offering a glimpse into the processes that lead to the birth of stars and planetary systems. This could answer fundamental questions about the origins of our own solar system and the potential for life elsewhere in the universe. One of JWST's most anticipated observations is of the TRAPPIST-1 system, which contains 7 Earth-sized planets, 3 of which lie in the star's habitable zone. JWST's detailed studies of these planets' atmospheres could reveal whether conditions might be right for liquid water, a key ingredient for life as we know it. Beyond its scientific objectives, JWST represents a triumph of international collaboration. NASA, the European Space Agency, and the Canadian Space Agency all contributed to its design and construction, bringing together decades of expertise in space science and technology. However, the road to JWST's launch was not without its challenges. The project faced numerous delays, cost overruns, and technical setbacks, but the successful deployment and early results have silenced many of the critics. Now, JWST is poised to revolutionize our understanding of the universe, pushing the boundaries of what we can observe and discover. As JWST continues to send back data, scientists are eager to see what new surprises it will reveal. From discovering new types of celestial objects to refining our understanding of the cosmic expansion, the telescope's contributions will be pivotal for decades to come. In the coming years, JWST will operate alongside other upcoming missions, like the Nancy Grace Roman Space Telescope and the European Space Agency's Ariel mission, which will further our understanding of the cosmos. Together, these missions will form a comprehensive suite of tools for exploring the universe. JWST's legacy will not just be in the images it captures or the data it sends back, but in the new questions it inspires. Every discovery opens a door to a new frontier of exploration, reminding us that there is still so much to learn about the universe we inhabit. So, as we look up at the night sky, know that JWST is out there, peering deeper into the cosmos than ever before, bringing us closer to answering some of humanity's most profound questions. How did we get here? Are we alone? And what is our place in the vast universe? Let's talk about artificial intelligence and creativity. AI is transforming how we create and interact with art, music, and literature. Models like DALL-E and GPT use deep learning to generate stunning visuals, compose music, and even write stories. By analyzing vast data sets, these AI systems can generate unique and innovative content that sometimes rivals the work of human creators. AI is not just a tool, it's becoming a collaborator. Artists use AI to generate new ideas, musicians rely on it for inspiration, and writers use AI-generated text as a starting point for their work. This fusion of human creativity and machine intelligence is opening new frontiers in artistic expression. However, AI and creativity raises important questions about authorship and intellectual property. Who owns AI-generated content? Should credit go to the algorithm, the programmer, or the user who guided the AI? These are pressing issues as AI continues to influence creative industries, challenging traditional notions of creativity and ownership. Beyond individual artworks, AI is being used to solve complex problems in creative industries. For instance, AI can analyze consumer preferences and trends, helping companies tailor their products and marketing strategies more effectively. It can also predict which songs or movies are likely to be hits, influencing decisions in the entertainment industry. But the impact of AI in creativity extends beyond commercial use. It's also being used for therapeutic and educational purposes. AI-driven art therapy is helping people express their emotions and work through challenges in ways that were previously difficult or inaccessible. In education, AI tools are personalizing learning experiences, helping students explore their creativity in new and engaging ways. As AI becomes more integrated into creative processes, it also opens the door to new art forms that were previously impossible. Generative art, where algorithms create ever-evolving pieces, challenges our perception of art as a static medium. AI-generated music that adapts in real time to the listener's mood or environment is another exciting development, pushing the boundaries of what we consider music. However, this rise of AI-generated content also brings challenges. Deepfakes, which use AI to create realistic but false images and videos, pose significant ethical and security concerns. As AI tools become more powerful, distinguishing between human-created and machine-generated content will become increasingly difficult, raising questions about authenticity and trust. To navigate these challenges, it's essential to develop ethical guidelines and policies that balance the benefits of AI and creativity with the need to protect human creativity and cultural heritage. By setting standards for transparency, consent, and accountability, we can ensure that AI enhances rather than undermines the creative process. In conclusion, AI is reshaping the landscape of creativity. It offers incredible opportunities to expand artistic expression, solve complex problems, and engage audiences in new ways. But as with any powerful tool, its impact will depend on how we choose to use it. By embracing AI's potential while addressing its challenges, we can create a future where human and machine creativity coexist and thrive, opening doors to artistic possibilities we've yet to imagine. Let's talk about quantum computing, a groundbreaking technology that leverages the strange properties of quantum mechanics to perform calculations far beyond the capabilities of classical computers. Quantum computers use qubits, which can exist in multiple states simultaneously thanks to superposition. This allows them to process a vast number of possibilities at once, making them incredibly powerful for solving complex problems. One of the most promising applications of quantum computing is in cryptography. Quantum algorithms like Shor's algorithm can factor large numbers exponentially faster than the best classical algorithms, posing a threat to current encryption methods. However, quantum computing also offers solutions, such as quantum key distribution, which can make communications virtually unbreakable. In the field of material science, quantum computing is being used to simulate molecular structures at an atomic level, which could lead to breakthroughs in drug discovery and the development of new materials. For instance, it could help design more efficient solar cells or new pharmaceuticals by accurately predicting how molecules behave. The delicate environment required for qubits is a major challenge. Even the slightest disturbance from heat or electromagnetic fields can cause errors. Researchers are working on developing more stable qubits and advanced error correction techniques. Surface codes, for instance, distribute quantum information across a grid of qubits, allowing the system to detect and correct errors without disrupting the overall computation. Another key concept in quantum computing is entanglement, where pairs of qubits become interconnected in ways that their states cannot be described independently of each other. This unique property is being explored for quantum teleportation, which could revolutionize data transfer by allowing information to be transmitted instantaneously between entangled particles, regardless of distance. Companies like IBM, Google, and D-Wave are at the forefront of quantum computing research, racing to build the first commercially viable quantum computer. Their work is paving the way for new industries and transforming fields ranging from finance to logistics. Imagine a future where quantum computers optimize complex supply chains in real time, model financial markets with unprecedented accuracy, or even solve problems in climate modeling that are currently beyond our computational reach. However, the development of quantum computing is not without its challenges. Scalability is a major hurdle. Scaling up from dozens to millions of qubits is essential for practical applications, and researchers are exploring new materials and architectures to achieve this. The potential impact of quantum computing on society is profound. It promises to unlock new scientific discoveries, enhance security, and drive economic growth. But it also requires us to rethink our current technological infrastructure, from developing new quantum-resistant encryption methods to training a new generation of quantum-aware professionals. As we stand on the cusp of the quantum era, the possibilities are as vast as they are exciting. Quantum computing is not just about building faster computers. It's about fundamentally changing how we solve problems, understand the universe, and shape the future. Let's talk about advancements in biotechnology. Recent developments are enhancing our understanding of aging and improving health span. Researchers are identifying genes associated with longevity and developing therapies to target cellular senescence. Senolytics, for example, are drugs designed to eliminate senescent cells that contribute to aging and age-related diseases. Stem cell therapies and pharmacological interventions like rapamycin and metformin are also being studied for their potential to extend lifespan and improve health in older adults. Biotechnology is not just about extending life. It's also about enhancing quality of life. Gene therapies are being developed to treat a variety of genetic disorders, from cystic fibrosis to certain forms of blindness. By correcting faulty genes at the source, these therapies have the potential to cure diseases that were once considered untreatable. Visualize cutting-edge labs where scientists are using CRISPR technology to edit genes, creating targeted treatments that address the root causes of disease rather than just managing symptoms. This precision medicine approach is paving the way for more effective and personalized treatments. Another area where biotechnology is making strides is in regenerative medicine. Imagine being able to grow replacement tissues and organs from a patient's own cells, reducing the need for organ transplants and the risk of rejection. This is becoming increasingly possible with advances in stem cell research and tissue engineering. Biotechnology also plays a crucial role in agriculture, helping to develop crops that are more resistant to pests, diseases, and environmental stresses. These innovations are essential for securing food supplies and reducing the environmental impact of farming. In addition to improving crop yields, biotech advances are leading to the development of foods with enhanced nutritional profiles, such as biofortified crops that provide essential vitamins and minerals. However, as with any powerful technology, biotechnology comes with ethical considerations. The ability to edit genes raises questions about the limits of human intervention in nature. Should we edit the genes of future generations to enhance traits like intelligence or physical abilities? Where do we draw the line between treatment and enhancement? These are complex questions that society must grapple with as biotech continues to evolve. Ensuring that the benefits of biotechnology are shared equitably is another challenge. Access to advanced treatments can be limited by cost and availability, raising concerns about healthcare disparities. Policymakers, scientists, and the public will need to work together to navigate these issues and ensure that the promise of biotechnology is realized for all. As we look to the future, the potential of biotechnology is vast. From eradicating genetic diseases to enhancing human capabilities and revolutionizing agriculture, biotech is set to transform our world in profound ways. By embracing these advances responsibly, we can build a healthier, more sustainable future for everyone. Thank you for joining me on this journey through the wonders of modern science. Until next time, keep exploring and stay curious. If you like our content, please don't forget to subscribe and follow our channel. Thank you for your support.